The holding beakers are identified by writing HCl on one, NaOH on another, and sample on a third. A little more than 50 milliliters of 10th normal hydrochloric acid is poured into the HCl holding beaker, and then a little more than 50 milliliters of 10th normal sodium hydroxide is poured into the sodium hydroxide beaker. The beakers are both covered with watch glasses. The hydrochloric acid burette is labeled HCl, and then the sodium hydroxide burette is labeled NaOH. The sodium hydroxide and hydrochloric acid in the holding beakers are used to triple rinse and fill both burettes as the sodium hydroxide burette shown here. After filling, the burettes are capped with a medicine cup. There's no reason to demonstrate the hydrochloric acid because it is handled the same way. Titrant is run out of the burettes while briskly rotating the stopcock across the opening. This expels any air bubbles that may be stuck in the stopcock. The sample beaker is put into position under the hydrochloric acid burette. A sample volume of close to 10 milliliters is desired, so 10 milliliters are added from the burette. The demonstrator marks the volume with her thumb and starts running 10th normal hydrochloric acid into the beaker until the meniscus gets to the marked spot. There are now approximately 10 milliliters of 10th normal hydrochloric acid in the sample beaker. The demonstrator adds 2 to 4 drops of phenolphthalein to the sample beaker. Notice the solution is still colorless. When everything is lined up so the titrant will fall into the beaker, the titration commences, slowly at first, until there is some idea of how much titrant is needed to do the titration. In the beginning of the titration, small flashes of pink show in the small volume where the titrant enters before getting mixed into the rest of the solution. As the titration gets closer to the end point, the pink flashes last longer and longer, necessitating the rate of titrant addition to be lowered to drops. When the titration gets to the point where each drop of titrant nearly turns the entire volume pink before going back to clear, it is time to slow down to 1 drop at a time, stopping between drops to see if the pink color stays. When the pink color stays, no matter how pale, that is the end point. The end point can be overshot. In this case, we will just add 5 more milliliters of sodium hydroxide to simulate this. Notice how vibrantly pink it is past the end point like this. This bright saturated pink is a strong indication that the endpoint has been overshot. We are now back titrating with the 10th normal hydrochloric acid. You will notice something of a reverse of what happened when we titrated the HCl with sodium hydroxide. Small volumes of clear in an otherwise dark solution are not as easy to see as small areas of dark in an otherwise clear solution. So the endpoint kind of sneaks up on you in this titration. Near the endpoint, when the volumes of clear are large, they are quite visible.